everyone, now it's me again. We are on our lecture note 3 of 3, still under chapter 1, topic number system, subtopic complex number. Okay, so complex number is quite new to you, right? Complex number is a combination, it's a combination of real number and imaginary number that can be expressed in the form of x plus yi, where x is the real number and y is the imaginary. Okay, x is real and y is the imaginary. I here denoted that y is the imaginary part. And I is known as the imaginary number that satisfies the equation I equal to Z negative I. So this is the definition of the I. I is equal to Z of negative 1, or I square. When you square both sides, it will become I square equal to negative 1. And complex number can be written as Z equal to X plus YI, known as Cartesian form, where x is the real part and y is the imaginary part of the complex number. So by definition, I equal to negative a set of negative 1. So when we square both sides, it will become I square equal to negative 1, and it continues for I cube. You can see the process here. Try to understand the process that goes on here. Try to do it by yourself. Okay. The important thing is you know the definition. This is the definition. So everything down below here starting from this very important definition. Okay. So we try to look at example 12. Where is the example 12? This is the example 12. Now, the first thing is we need to simplify this because we noticed that from our previous lesson, from your what you have go through during your Form 4, Form 5, square root cannot be negative. Okay? Right? But it is important for us to know that before this, we are going through this definition whereby I is equal to set of negative 1. Right? From our definition from the previous page, I is equal to set of negative 1. So, we need to rewrite this in the form of negative 4 is equal to negative 1 multiplied by 4. Right? And by the law of sets, we can separate it or break this up into become a separate set, negative 1 multiplied by set of 4. Can we solve this? Okay, again, by definition, this is that we get from our previous page, which is set of negative 1 is equal to I. So this one, we can write it as I. What about set of 4? Set of 4 is equal to 2. So, this one is equal to 2. Our final answer is 2I. Right? So whatever it is goes to our definition. Okay, what's our definition again? I is equal to set of negative 1. That's a very simple example, right? Now we go to more complex one. Okay, we go to example D. Can we go to example D, class? Right, go to your example D, whereby we have -2 minus set of -48 divided by 2. So again, here, okay, negative of set, negative 48, set of negative 48, we can break up to, it's actually set of negative 16 multiplied by 3, right? Okay. Okay, so from here we can break this into set of -1 multiplied by 16 multiplied by 3. Is it? Okay, now we go to our equation. So this one, it will be -2 minus, okay, I want to put -1 at the back. So this one becomes 16 multiplied by 3 multiplied by -1. Because we know from our definition, set of -1 is equal to set of -1 equal to, yes. So this one, it will become -2 minus set of, by law of set, you can break this up, right, into one by one. Set 16 multiply by set of 3 multiply by set of -1. Okay, so I think you can set of -16 multiply by set of 3 multiply by set of -1 divided by 2. And this one will become, I don't have enough space here, but it's okay as long as you can understand what I mean, so that's no problem. We have here 4 set 3i over 2. Okay, is that the final answer? Not yet, because final answer means very final. You cannot do anything anymore. So now, as we can see, we can, okay, this one become 1, this one become 2. So our final answer is -1 minus 2 set 3i. Okay, so that is final answer. We cannot do anything anymore. We cannot simplify it anymore. Okay. Now we go to operations that involving complex number. Before this, we go through definition, right? So we are done with the definition. We go to the complex number operation. Okay, to add or subtract the complex number, we simply add the real part separately and the imaginary part separately to get a new complex number. So as we can see here, we have two complex number here, but at the end of it, we will add the real part separately from the imaginary part, okay, and we get a new complex number there, right? We add A together with C because this A and C, A here is real part, okay, so that's why A plus C, and B here is the imaginary part, that's why B plus D. Okay, and the same thing we do with the subtraction. We minus the real part separately from the imaginary part. This is the imaginary. Okay, so it's very simple for addition and subtraction. Right, so that's for addition. For addition and subtraction, we separately add or subtract the real part and the imaginary part. So we get a new complex number. Now we go to multiplication of complex number. Okay, for multiplication of complex number, what can you see here? Okay, actually the general idea is you can multiply complex number just like you multiply a traditional binomial. Okay, so just like this. So as you can see here, it's actually like we multiply our traditional binomial to binomial. So this one, okay, like this. So at the end, you will get this. How to get this? We get AC plus ADI plus CBI plus BDI square. And I square is equal to -1, right? So AC minus BD plus CB plus AD here, I. Okay. So why it become like this? Because I square here will become -1. That's why after this, we can notice that I square here will eliminate and it changed to -1. That's why AC minus BD, we get this. Okay. Now we go to example. Straight away go to the example. We try to solve example 13 first, focusing on both A and B. So for this one, what should we do? We simply just do a normal operation here. This one become 12 minus 9i minus 10 plus 25i. So this one involving addition and subtraction of complex number. We will add or subtract the real part separately with the imaginary part. So it will become 12 minus 10. Okay, 12 minus 10. This one we have plus -9 plus 25i. So here it will become 2 plus 16i. So this is the final answer. Okay, very simple. And now we go to the multiplication of two complex number. Okay, so just like a normal multiplication, set 3, we just expand the bracket, right? The general idea is just like we expand the bracket. We have -I, set 3, set 5, plus I, set 5, set 3, minus I square, set 5 square. So at the end we get 3. Okay, this one will eliminate, right? Because negative here plus, then we don't have it anymore. And this one I square equal to -1. So negative multiplied by negative, we get the positive. So plus by 5. So at the end we get 8. We must be very careful. Okay, when do maths, you need to be very, very careful. Okay, that's it for example 13. And then we go to now equality of two complex numbers. Alright. So now we need to, example 14, determine the values of x and y. Okay, just compare left together with the right. So when you have symbol of equal here, meaning left is equal to right, so we just compare. So to compare this, we need to solve this and make sure we get a correct answer. 5 multiplied by 3, we get 15 plus 5i minus 3i minus I squared. Okay, so from here, by definition, I squared is equal to negative 1. So, 15 plus 5 minus 3 equal to 2i minus negative 1 here. So, here we get 15 plus 2i plus 1. And final answer is 16 plus 2i. So at the end, by comparing, get x is equal to 16 and y equal to 2. Right? Okay, and that's it. Okay. Now we go to conjugate of a complex number. For previous example, you can try to do it by yourself. Okay, we cannot solve everything in this video. We go to a conjugate of a complex number. Okay, so two complex number which have equal real parts. Okay, they need to have equal real parts but opposite sign of imaginary parts are called complex number. They have what? Opposite sign of what? Imaginary parts. Wow, to highlight that. So I mean it's very important. Please notice this. Opposite sign in the imaginary parts are called complex conjugate. Okay, where when we have z equal to a plus bi, then its conjugate written as z. This the symbol in up of the z, meaning the one here, okay, up here, referring to the complex conjugate, is equal to a minus bi. Okay, they are different in the imaginary parts. Okay, the symbol is completely different, opposite to each other. So for example, we can try to solve A. Example 16a. Okay, here. How to solve this? We need to, for a fraction, we don't want the denominator in the form of I. So what should we do for that? Okay, how to eliminate the I? We need to multiply by the conjugate. Okay, what's the conjugate for 3i? Negative 3i. So that's what should we do? Okay, so we multiply the numerator and the denominator by its complex conjugate, which is multiply by negative 3i. So, negative 3i. Now, our fraction will become 2 minus 3i multiplied by negative 3i over 3i multiplied by negative 3i. Okay, so now we can clearly see that now it becomes 6 negative 6i plus 9i squared over negative 9i squared. Okay, what happened to the I squared? So by definition, From our previous page, we get that I square equal to -1. So negative 6i plus 9, -1 here. Down below here also -1. So now we get negative 6i minus 9 over 9. So is that the final answer? Not yet, because we can still simplify this. How to simplify this? So this one will become 3. This one will become 3. This one will become 2, right? So at the end, it will become -3 minus 2i over 3. Final answer is -1 minus 2i. Okay, because normally we put the real part in front and the imaginary part come after it. Okay, that's why, just to make it look normal. If not, it's look abnormal. So we want to make it look normal. Okay, this is the answer. -1 minus, 2 over 3 here. Okay, 2 over 3. -1 minus 2 over 3i. Okay, so go through step by step slowly. Don't have to rush. If not, you will make a mistake. Make sure you don't make any mistake. Okay, that's for example 16a. Let's go to example 16c. Okay, like our a, so what should we do to solve this fraction? We need to multiply by the conjugate. Conjugate of what? Numerator or denominator? Absolutely the denominator. Okay, please don't get confused. Conjugate of the denominator. Okay, any fractions also we solve fraction with the complex conjugate of the denominator. Meaning we don't do anything with the numerator. Okay, they just follow. So here we need to multiply by, what's the complex conjugate of the denominator? -2 plus 5i, because the imaginary part is completely opposite from the one that's not conjugate we want to conjugate with. So -2 plus 5i here. Now we can solve it. How to solve? So this one, it will become 11 minus 2i, -2 plus 5i over -2 minus 5i multiplied by -2 plus 5i. Okay, so for a conjugate, we still use this formula whereby a minus b multiplied by a plus b equal to a square minus b square. Okay, so for this one, you want to do a more difficult operation. So this one here, down below here, for the denominator, it will become, by using this formula, so a is -2, right? -2, oh sorry, oh, oops. So our -2 will be square minus our b is, what is our b? Our b is 5i squared. Our b is 5i. Our a is -2. Our b is 5i. Okay. So, okay, the operation up here is, okay, here, -22 plus 55i plus 4i minus 10i squared. Are you following me? Okay, I hope you are. So now, just solve everything, do it properly. So -22 plus 55i plus 4i. So this one, I square, it will become -1. So -1 multiplied by negative become positive. So here we plus 10. Okay, over this one will become 4 minus 25. I square will become -1. Negative multiplied by negative become positive, right? So this one plus 25. Is it? So now it will become -22 plus 10 become -12 plus 59i over 29. So our final answer, either you want to put it in that. So better we put this in this version to make it look more normal. Plus 59 over 29i. So that's our final answer. So that's all, class, for today's lesson, for this video. Thank you for your cooperation and attention.